Hi, my name is Yunchou Xing. I'm a PhD candidate of Professor Rappaport, and here is our project on 140 GHz channel sounding, and this is our fourth generation channel sounder. Previously, we worked on 28, 38, 73 GHz, and now we move to 140 GHz, which there are like a lot of bandwidth. For now, we work on a 4 GHz bandwidth, which is much wider than previous in the previous communication history used. And we transmit a signal from the transmitter, get a signal at the receiver. And you can see that if we block the antennas, the power levels will go down. And when we move the block away from the antennas, the power levels can go up. It shows how the power changes when people pass by and when the blockage occurs. And also you can see that we have already made some initial measurements on free space propagation and penetration loss. For the free space path loss, the 140 GHz did not have too much difference than the previous frequency. It only has a gap, but the slope is constant. So we can still use the path loss models used for frequency below 100 GHz. And also we have some initial measurements on the penetration loss of common indoor materials like clear glass, glass door, and drywalls. We can see that the penetration loss increase at a higher frequency, but for 140 GHz, it can still be used for indoor like Wi-Fi applications. Also, we have some other research on position locationing. I will let my colleague Ojas to show his research.
Hi, my project is on wideband position locationing in mmWave wireless communication systems. What I'm going to do is I'm going to leverage the huge amounts of bandwidth available at mmWave systems to do precise positioning. Precise positioning is particularly important in locations where GPS is not available. For example, indoors and in factories, in smart factories where you want to know the location of objects to automate them. Or for example, when firefighters want to enter a smoking building and they can't see anywhere, you need precise position locationing in those cases. What I have done is, based on the data we collected 4 years ago, I have fused two main positioning algorithms, the angular variable based positioning and the path loss based positioning. And I have located several RX locations based on this algorithm. So currently the accuracy of this system is sub 4 meters, and I plan to improve the accuracy of positioning by also using the time of flight of the signals. So I'll be fingerprinting the entire floor with my colleagues in the summer, and using these measurements, I'll create a database and I'll match the measured values of the time of flight, angular variable, and power with the database values to get precise positioning.